This lack of understanding has hampered every computer program that's tackled human language. A perfect example is a program from the 1960s called ELIZA.
ELIZA was one of the first programs that had anything resembling human conversation. It was a dialogue. You type things in and type things back.
How do you do? Please tell me your problem.
I'm feeling sad. Then it types back. Did you come to me because you're feeling sad?
ELIZA was programmed to respond like a psychiatrist, but it had no real insight. Instead, it followed simple rules and rearranged key phrases.
So if I say, I'm dead, it responds, do you enjoy being dead? It doesn't have any understanding that dead is a different kind of condition. It really is just doing this sort of fill-in-the-blanks kind of pattern matching.
Anyone who tried to solve the language problem hit the same brick wall: the computer's profound ignorance of what we take for granted every day.
There's just so much more that we know that we don't know we know. I mean, just we know all kinds of stuff, like you press the up button in the elevator, that means it's going to go up. Or milk is white, or water is wet. I mean, there's just stuff that we know that we don't even realize we know. That's one of the things that makes it hard.
All the common sense knowledge a human brain collects naturally seems much too complex to program into a computer. But that hasn't stopped one scientist from trying.
So we have actually manually entered about 6 million rules. That's about 3% of what it's going to need to know in terms of actually spanning what you and I would call human common sense.
For the last 25 years, Doug Lennott has been leading a team trying to create human-like intelligence by teaching a computer common sense, rule by rule. The program is called Psych, and at headquarters the walls are covered with logic diagrams.
In a way, the magic of this, the power of this, is if you just tell it each rule one by one by one, and you give it general logical reasoning capabilities, that's all you need to do.
So far, Psych has 6 million rules and can answer a lot of common sense questions, like this one.
Can.
Psych says no, and it explains why.
Here, it's essentially saying the reason why cans can't can is that cans are inanimate objects, and it knows that can dancing requires at least partially having a brain and using it. It's just enough for Psych to get the right answer for the right reason.
25 years ago, many experts considered rules and logic the best hope for building artificial intelligence. But it's become clear these alone are not enough.
It's not just a matter of piling in more and more stuff. There are basic principles that we didn't understand. Putting in more and more stuff doesn't get you basic principles.
At IBM, as Dave Ferrucci and his team tackle the Jeopardy challenge, they know that facts and rules are just the beginning.
We couldn't write rules for every combination of word and phrases and context.
They need a new system, more fluid and flexible, to navigate the twists and turns of many different kinds of Jeopardy questions. They named their system Watson, after IBM founder Thomas Watson. The electronic Watson consists of 2,800 processors. That's like 6,000 high-end home computers. Altogether, it's the size of 10 refrigerators. The team starts filling his memory banks with about 10 million documents, most downloaded from the internet. Because when Watson plays Jeopardy, he must stand alone, just like his human competitors.
All kinds of content, okay, encyclopedias, dictionaries, thesauri, books, plays, you name it.
The entire World Book Encyclopedia, Wikipedia, the Internet Movie Database, much of the New York Times archive, and the Bible are just some of Watson's resources. And to build on Watson's foundation of data and rules, the team turns to a powerful tool in the computing world. It's called machine learning.
Machine learning is just like human learning from examples.
Before, people would just write rules by hand. Nowadays, it's all based on examples.
To understand how machine learning works, consider for a moment the letter A. What if you had to describe it to a computer? It's a real problem faced by the U.S. Postal Service, whose computers must decipher all kinds of addresses, printed and handwritten.
We all know what an A looks like. I know when I see it, but there's just way too many different types of A's. There are fonts where the A is just a triangle pointing up. Right? That's an A. Pretty quickly you realize there is no simple set of rules that you can write down currently for a program to determine whether a letter is an A or not.
Humans might not be able to come up with the rules that reliably identify all kinds of A's, but it turns out a computer can do it for itself, if you give it enough examples.
The way you do it is you just get an A, send it to the program, and say, that's an A. Here's another A, different one, that's an A. Here's another A, it's a different one, that's an A. Then you would give it another example, then you would give it another example, and you would do that 1,000,000 times.
The computer hunts for patterns among all those examples, and it finds them. So the next time it meets a letter A, even one it hasn't seen before, it will recognize it. This is machine learning, and it's a crucial element of Watson's programming. The team trains Watson. But here, instead of letters, the examples are tens of thousands of old Jeopardy questions, along with a cheat sheet of all the correct answers. Using machine learning, Watson will hunt for patterns between the type of question, the correct answer, and the kinds of evidence that support that answer.
Now, we do this over thousands of questions, so we come up with some way to weigh the evidence on average so that we come up with the right answer.
Now, when he's faced with a brand new question, Watson uses what he'd learned from these patterns and declares his confidence in each possible answer.
In the end, we get a list that says, here's the top answer, and we're 75% sure it's right.
Watson has now become a complex architecture of rules, raw data, and machine learning that enables him to use statistics to choose the right answer. To test out this system, the team scours the halls for IBM employees who can play Jeopardy! And everyone squeezes into a conference room.
In 1978, New Jersey monthly reporter Stephen Levy famously found this man's brain. Watson.
What is Einstein's?
Albert Einstein's, yes. The Fifth Amendment says that private property shall not be taken for public use without this. Watson.
What is just compensation?
Yes.
With this new system, Watson searches into the winner's cloud.
We took a huge jump with machine learning.
Watson with a commanding lead, 24,863.
We saw a huge jump in performance, and we were like, woo!
Up to now, appearing on the TV show has only been a dream. But Watson is performing so well, Dave Ferrucci decides it's time to call Jeopardy! In December 2009, Jeopardy! Producers arrive at IBM to size up Dave Ferrucci's new creation. Like any human contestant, Watson must audition to earn his spot on the show.
You spent all this time, developing the system and pushing its capabilities. Then here you are, sitting here, all the executives are there.
You hear computer, you think, well, of course a computer should have all the answers. You hear about Q&A technology, well, isn't this just a big search engine?
And they're waiting to see, what really is going to happen, and you just don't know. You don't know.
To impress the executives, IBM builds a makeshift studio, hires comedian Todd Crane to act as game show host, and brings in former TV contestants.
That was one of the tensest days I've ever had, because we had never seen it play against Jeopardy players.
Select again, Dave.
And I remember, like, the day before, we're tuning everything. I was putting in the best strategy that we had. I was putting the best stuff that we had. And I thought, well, this is just going to kill him.
Miranda.
What is the Cats in the Cradle?
That's correct.
Is I Am the Walrus?
Yes.
What is Crocodile Rock?
Yes.
They were just like professional athletes. It was a really tough few games for us.
In the first round, it seems that Watson is auditioning not for a game show, but a sitcom.
Where do we go next?
L underscore 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 over 1,000.
There are suddenly unexpected bugs that need fixing.
We weren't dealing with Roman numerals well, so it'll say like Henry V. We would say Henry V.
In 1682, he came to the throne at the age of 10, along with his weak-minded half-brother, Ivan V. Watson?
What is Peter?
More specific?
What is Peter I?
No. Carrie or David? Carrie?
Who's Peter the Great?
That is correct. Peter the...
In Final Jeopardy, where contestants must place bets and write down the answer, things only get worse.
No.
Under the category Flags, the clue is, in a policy begun in 2002 as a symbol of the war on terrorism, U.S. Navy ships fly the 18th century flag with this four-word motto.
You did know a little bit something about 18th century flags. David, let's see if you did. What is the four-word motto we're looking for, David?
What is "Don't Tread on Me"?
That is correct. Let's see if Watson got it right. What is September 11th?
Watson didn't recognize the word motto, and after scanning through millions of documents, he found the word terrorism associated with September 11th so frequently. That seemed like the best answer. By the time they break for lunch, it's Humans 2, Watson 0. And it's not clear if Watson will ever be ready for primetime.
This was taking a risk for me in the sense that you're sitting here and saying, you know what, I think this is possible, and then you fall flat on your face, and people say, well, we're never going to believe Ferrucci again. Did I expect to get fired? No, but maybe.
But after lunch, the producers are treated to a different side of Watson.
We came back, and the third game was neck and neck, incredibly competitive.
In Act 3 of an 1846 Verdi opera, this scourge of God is stabbed to death by his lover, Ottobella. Watson?
What is Attila?
Be more specific?
What is Attila the Hunt?
Thank you very much. Attila the Hun, I'll take that.
That afternoon, Watson climbs back in the game.
Wordsworth said they soar, but never roam. This Brit, Watson?
What is Skylark?
That is correct. It's a device clamped to the wheel of a parked car with overdue tickets. That is correct. Watson?
What is Boot?
Be more specific?
What is Denver Boot?
That is correct. This African-American folklore laborer. Before I let that steam drill beat me down, I'll die with my hammer in my hand. Watson?
What is John Henry?
That is correct. Select again, Watson.
It may appear that Watson has redeemed himself, but the producers are troubled by his erratic performance. Their verdict, Watson isn't strong enough for Jeopardy. At least, not yet. Why is Watson so erratic? To understand his weaknesses, you have to appreciate the complexity of the task. Consider this clue. Keanu Reeves had a Nokia phone, but it took a landline to slip in and out of this, the title of a 1999 sci-fi flick. The correct response is what is the Matrix? But how can Watson figure that out? First, he breaks down the clue into grammatical parts, identifying key words and phrases. Then, Watson's powerful search engines churn through millions of documents, including the Internet Movie Database.
What we do next is we take these documents and we pull out candidate answers. And we'll pull out, okay, Keanu Reeves. That could be a candidate. We'll pull out Nokia. We'll pull out The Matrix.
Other movies starring Keanu Reeves also become possible answers.
We'll pull out The Matrix 2. We'll pull out Speed, Bill and Ted's Excellent Adventure, all this stuff.
Whoa. And Watson pulls out other famous sci-fi flicks, like Blade Runner.
And it generates hundreds of possible answers.
With hundreds of choices, how can Watson pick the one answer that's correct?
Next thing that Watson is going to do is going to take those answers and say, well, let's assume all of them might be right. So these are its competing hypotheses.
Watson starts considering evidence for and against each candidate, using rules like a movie is sometimes called a flick.
And we'll look at things like, well, it's looking for a flick. Is this candidate answer a flick? Is The Matrix a flick? Yes. Is Speed a flick? Yes. Is Keanu Reeves a flick? No. Right, so we're starting to learn something.
Within a matter of milliseconds, Watson analyzes every possible answer in hundreds of different ways and scores each piece of evidence behind every answer in the list. That's a lot of scores.
Problem is, you have all these different scores and they don't agree.